We're starting to talk about absolute value equations today, and so we have a lot of just kind of definition type stuff to get through first. So let's do that before we actually start solving some problems. The concept of absolute value has many uses. The absolute value of a number is its distance from zero. So the example I was giving in class today was if you thought about how far away from home are you at any point. So if you live in San Antonio, you drove up 281, you were 6 miles away from home. Going north, you would just say I'm 6 miles away. If you drove 4 miles south from your house, you wouldn't say I'm -4 miles away from home. You would say I'm exactly 4 miles away. So distance, you're looking at your distance from zero. So if we look at the number line, we can see we have a number here that is 4 away, and then even if we're at -6, that one is just 6 away. So we're not -6 away, I'm 6 away. So the absolute value of x see if I can write it out. The absolute value of x denoted by basically two perpendicular lines that are parallel to each other, and it's read as the absolute value of x is the distance of x from zero. This is why absolute value is never negative. It's never negative. Always positive. You're never a negative distance away from something. Absolute value only asks how far, not in which direction. This means not only that the absolute value of 3 equals 3, because 3 is 3 units to the right of 0, but also that absolute value of -3 equals 3, because -3 is 3 units to the left of 0. Just ask yourself, how far away from 0 am I? So you can see here is 3, and here is 3. Sorry for my drawing, not great, but you get the idea. And then we have a few more simplifications. Simplify absolute value of -8. -8 is over here somewhere. And when they're asking that, you're just saying it's 8 units away. 0 minus 6, that's going to put you at the -6. But your absolute value is still just 6. And then 5 minus 2, well, last time I checked that's 3. So you're just 3 units away. Now, getting on to a little more difficult stuff, when you're dealing with variables. You have variables like x and y. You cannot tell the sign of the number or the value that is contained in the variable. For instance, given the variable x, you don't know if it's positive or negative. If it's 2, -4, whatever it is, you don't know. So we have a few rules. If x is greater than 0, or if x is positive, then the value won't change when you take the absolute value. So if x equals 2, then absolute value of x equals absolute value of 2, which is also 2, which is equal to x. In fact, for any positive value of x, or if x equals 0, the sign would be unchanged. So for x greater than or equal to 0, the absolute value of x equals x. On the other hand, if x is less than 0 or negative, then it will change its sign when you take the absolute value. For example, if x equals -4, then the absolute value of x equals the absolute value of -4, which is +4, which equals the opposite of -4, so it's actually the opposite of x. In fact, for any negative value of x, the sign would have to be changed. So that can be a little confusing, but just remember you need to stay positive. So for x less than 0, the absolute value of x equals -x, or the opposite of x. Okay? Now let's go to the back side of the page. So give me a second here, and we'll get to the back side. Okay. So we are continuing on. This is a case in which the minus sign on the variable does not indicate a number to the left of 0, but a change of the sign from whatever the sign originally was. The minus sign does not mean the number is negative, but it means that I've changed the sign. And I usually say the opposite. So must the opposite of x be negative? Why or why not? We would say no, it does not have to be negative. If the original value of x was negative, then the opposite of x, the opposite sign version of x, would have to be positive. If you started with x equals negative 3, the opposite version of that is x equals positive 3. So, because of this, when solving for absolute value equations, we have to solve for two equations. Example, absolute value 5 equals 5 and negative 5. Now, I'm going to work out problems on here. I'm not going to show you how I check my answers except in a couple of situations, but you should be aware that you need to check your answers. So when we have 5 times the absolute value of x equals 10, the first thing we want to do is divide by 5. Divide by 5. So your absolute value of x equals 2. So then I need to write my two equations. Anytime you gotta get the absolute value by itself when you're solving, and once you do, you write your two equations. The first is just the equation without the absolute value sign. The second is you make the absolute value part equal to the opposite. Now in this case, you have nothing else to do. And so when we would check our answers, we would plug these both back in. We would plug negative 2 into the original and positive 2 back into the original. In this case, when you do that, they both work. So our answers would be x equals 2 and negative 2. And if you were drawing that, your graph, I would just put 0 here. I go 1, 2, 1, 2. X equals 2. X is negative 2 right there. So that's kind of how you're drawing your graphs. When we have number 2, so just like the first one, we don't have to do anything to get the equation by itself. So, or unlike the first one, so we can just say 2x minus 1 equals 5. And then we would say 2x minus 1 equals negative 5. Those are our two equations because we already have the absolute value by itself. So then we solve. And a lot of people they saw this one and said, oh, I know it's 3, so it also has to be negative 3. That's not true. So I'm adding 1 to both sides. 2x equals 6. When I divide by 2, I end up with x equal to 3. So the 3 is right. But over here, when I do it, add 1, 2x equals negative 4. Then when I divide by 2, I get x equal to negative 2. And when I check both of those answers, they both work. So graphing my graph is going to look like this. Okay, so those are two pretty simple ones. Number 3, we start to get a little more difficult. We have more steps to get to where we're going to. So here, I need to get the absolute value by itself. I need to add 1 first to both sides. So I get 3 times x plus 2 equals 9. Then I'm going to divide by 3 for both sides to get rid of it. So then I have x plus 2 equal to 3. So now I have my two equations. They are x plus 2, oh sorry, you can't see that one. We'll be able to see it here in a second. X plus 2 equals 3, and x plus 2 equals negative 3. When I do those, I end up with x equal to 1 and x equal to negative 5, because in both cases I subtracted 2. And when I check those ones out, when I plug them back into the originals, they both work. They both work. I'm not going to draw the graph because I'm out of space, but you would put points at 1 and negative 5. Alright, so the next one is very similar, and I will leave that one for you. So I'm going to do number 5. And number 5, we have 3x plus 2, that's an absolute value, equals 4x minus plus 5. So we don't have to do anything to get it by itself, but now we have x's in both. So I'm going to write my two equations. Oh, excuse me. Without the absolute value, 3x plus 2 equals 4x plus 5, and 3x plus 2 equals, now I take the opposite, so I have negative times 4x plus 5. It's the opposite of 4x plus 5. So on the left-hand side, I'm going to solve first. And I'm going to say, I'm going to subtract 3x from both sides first, because I want to get those by themselves. So I have 2 equals x plus 5. Subtract the 5. And I get negative 3 equals x. On the right-hand side, I rewrite it. This is negative 4x minus 5 over here. 3x plus 2. I'm going to add 4x to both sides. So I'm going to have 7x plus 2 is equal to negative 5. Subtract 2, 7x equals negative 7, and I get x equals negative 1. Now I need to check my answers. When I do that, I plug this negative 3 back into the original equation. So I have 3 times negative 3 plus 2, all in the absolute value, equals 4 times negative 3 plus 5. So now I'm going to give you a little hint. I'm going to do the right-hand side first. I get negative 12 plus 5, which is negative 7. So on the left-hand side, I have an absolute value. You have to ask yourself the question, can an absolute value ever equal something negative? You can have negatives inside. So like I have a negative inside right here, that's fine. But I can't equal a negative outside over here. So that means it won't work. And so x does not equal negative 3. This is actually called my extraneous, and I'm going to put it up at the top, solution. And an extraneous solution happens quite a bit in absolute values because you're trying to find up to 2 answers, and there's a possibility that only one or even no answers actually work that you solved because of the reason I just said, where you can't have an absolute value equal something negative like it does here. When we do the same thing for negative 1, though, we can see we get 3 times negative 1 plus 2 inside absolute values, and that equals 4 times negative 1 plus 5. Sorry if it's not showing up perfectly, but you'll see it here in a second. And so that means we have negative 3 plus 2 in absolute values equal to negative 4 plus 5, and that is positive 1 and the absolute value of negative 1. So those two check out. So our one answer is x equal to negative 1. That's the only one that works. And there you can see all the work for all the problems we've done. I didn't do 6 and I didn't do 4. You can just follow the way we did 3 and 5. And those are the absolute value problems.